So from your investigation, this is simply what? The area bounded by this curve along the x-axis within this interval can be calculated directly by what? The what? The definite integral, not just integration. Okay? By calculating the definite integral, so basically our area will be the definite integral within from where to where? A to B of this function with respect to x. You should notice that in your investigation. Okay? So the second one we're going to do is when it is below. Did you notice something when it is below? I gave you a particular interval that is below. What number was that? Okay, so question 4. Was it question 4? Yeah. If a section of it was below, Calista, does it mean you didn't do this? You did? Okay. So below, what do you notice about the area below? When you did it? You have to take the absolute value because you have it to be negative, isn't it? So if it is below, it's going to be negative. So in your textbook, I think somewhere it was written that area below is minus something, area below the line or area below the x-axis, but we don't have to say that. So we can say 2. Okay, please write. Okay, maybe we can include that. Area below x-axis. Okay. So if you are dealing with area below x-axis, so let's say we have a curve that will be of this form. Okay, that will be of this form. So we are interested in the area from A to C, but there's a point B here. So this is y is equal to f of x again. Okay. So the area from x equals to A to x equals to B is still integral A to B f of x dx, but the area from x equals to B to x equals to C will give negative if you do direct integration. Okay? Since the region, okay, since the region is negative, the region is below, is below x-axis. Okay, so to find the area, we say that area is the absolute value of the integral. So therefore, area from A to C will simply be the integral A to B f of x dx plus the absolute value of the integral B to C f of x dx. Okay, this you must have noticed also in your investigation. The next two that I will write just me as a code. What? Who puts this in 19 degrees? Just for a sec. So the room can be warm. Sorry, Krista. I know you're having fun in this weather, but I'm dying, okay? I'm not from mainland. So the third one is as follows. Area bounded by two curves, okay? Area bounded by two curves. So let's say along your XY axis again. Maybe you don't even need the y-axis, only the x-axis is needed. So along the, maybe I could. All right. So let's say we have a curve F, maybe that goes this way, and a curve G. So let's say y equals f of x. And let's say there's another curve G that comes that way. Y equals g of x. So we're interested in the area bounded by these two curves. Everybody listen? We're interested in this area. Okay? To find this area, to find the area, the region is between maybe some points A and B also. Clearly that is the point of intersection of the two curves, right? To find these two areas, what do you notice in your investigation? The area here. Come on. I think by observation you can see from the board. You don't even have to look at it. If I need this area, forget about your investigation. If I need to find this area in maths, what would I do normally? But remember, I can always find the area below a curve and the x-axis. That is a standard thing that I know, at least from the first one. Okay, you can always find the area below a curve and bounded by the x-axis. So if you know that, how can you use that to find the area of this shaded part? Anyone want to try? Not Lillian. For any function, you can find the area below the function and bounded by the x-axis. But in this case, I want to find the area of that shaded region. What would you advise?
You take the area underneath f of x, and then subtract the area under g of x.
G.
Yeah.
That's it. Area under f of x is everything here. Area under f of x is this. Do you agree? This is area under f of x, between that interval. Now, what about the area under g of x? Area under g of x is this. I should have used the green and the red. You understand what I mean? Yeah. Okay. This area under G. So, how do I find the area of shaded region? Find the area below F, find the area below G, and do what? Subtract. Does that make sense? So, we can write this as follows. The area, this point A. Area A is the integral, yes, together. Come on, talk to me. Integral A to B, yes. F of x dx, minus integral A to B g of x dx. And you can use the property of definite integral to combine this. Yes? I want to write this as one integral. Yes, what it is? What is it?
A to B.
It's from A to B, integral from A to B.
F of x.
So it's going to be the same as f of x minus g of x. and everything dx. So that's the third part. And the final part, do you remember the last investigation along the y-axis? What did you do? I asked you to try different things, right? I asked you to try different things in the last one. First, I asked you to find the area by that region. You got what? You got 33 over 4. Is that? Talk to me, please. Number 5B. Did you get 33 over 4?
Yeah.
Then 5C, you were asked to find the direct integral if you are to use integral y dx. And you didn't get the same thing. Then I asked you to change the coordinate. Look. First, I asked you to find this by using normal area of triangle, because that shape is a trapezium actually. Right? You got a 3 over 4. Then I said, okay, can we try this also? Then you substitute this and you discover it's not the same. And I said, oh, maybe because these coordinates are x coordinates. Okay, let's find the y counterpart of the x coordinate. And there, those were y equals 2 and 5. Then you realize it's not the same as well, right? And the last thing I ask you to try is what? Find the inverse by making x the subject, isn't it? Okay? If you write y is equal to, x is equal to g of y, and you are able to find a function that can define this, isn't it? And when you substitute that, you realize it's the same, okay? So the idea here is that to find the area along y-axis, you know, for the one so far along x-axis, please look up. For the area along our x-axis, for areas along x-axis, you do integral y dx. That is the function itself, where a and b are the intervals that is being considered. So you are considering the function itself. Okay? But for the area along the y-axis, you are considering the inverse of the function. Am I making sense, please? Because there's a kind of reflection now. Okay? Look at it. Yeah, there's a kind of reflection from here to here. And you will remember there's the line y is equal to x, and one function gives you the reflection of the other. You can use that intuition to remember. So the area of this one is usually integral x dy. So the first thing you need to do is to make y the subject, to make x the subject. So let's write the steps as follows. For this, okay, 1, make x the subject. Okay, so that your x is now a function of y. Okay? Make x the subject of y equals f of x. Okay? So that x is equal to that. That is, your x is actually the f inverse of y. So I'm using f inverse to be a g this time. Okay? Then 2, the area is the integral of that inverse function between the given intervals with respect to y. So I say integral gy dy between the intervals. So in your formula booklet, it's just written as integral x dy, while this is written as integral y dx. So along the y-axis, that is what you will do. That was why I asked you to complete all this investigation, so you would have seen it yourself, even using a linear function. Any questions, please? Mr. B, is there a problem? So we're going to just focus on question quickly. Of course, the functions f, g, could be linear, could be exponential, could be trigonometric, understand? Could be a logarithmic function, could be a sum of two of these functions. So whatever it is, do not forget the idea is to find the integral, the definite integral, I mean, within that interval. So that's all about area under the curve. So we are just going to practice for the rest of the class using different questions. I was trying to make a worksheet, but there was no time to, but I'm still working on it. So once it is ready, I will give to you. But in the meantime, we can take some problems from the book. Supposed to see it by default, right?
Imported and imported.
Yeah, okay. Yeah. Should work now. Definite integral, area under the curve. Okay. And this is the calculator instruction for some of those things. Does everybody know how to use definite integral on the calculator? Okay, so let me show you that first. If you could, oh no, not you. If you could check your calculator of HP prime now. Yeah, calculator, Casio. Alright, let's try again. Alright, so your Casio, this is how you do that. So please follow the instruction and just try integral of x squared plus 1 within 1 and 2. Press F5, then F6, F3, Where's your calculator, miss? Class. You want to go get it? Because I will need you to master.
Yeah.
Oh. Okay, you give someone.
No, but I'm afraid I'm going.
You distract them. I'm not sure if that's the case. You can still go and just tell the teacher you want to get something. Because I will need you to use it in this class today. Did you get it? Raise your hand once you are able to try this. Where's your calculator, Miss Christus? Mrs. Christus? Where about Lillian's? You don't have? How can you not? What?
Mine's broke.
Broken. Oh, okay. I thought you said you are
How?
broke. I'm like,
The 789.
dude, how can you be broke?
I can't click the 789.
In your calculator. How old is your
3 plus
calculator?
4.
How old is your calculator? Because maybe you've been using the calculator since P6. Who knows? What about you? What? What is she saying?
It's so bad.
You didn't bring to school?
Because it's so heavy.
Are you serious? The calculator is heavy. Please, you need to please start bringing them in so that you get used to some of these functions, not the day of the exam. All right? I've shared all this in the folder before. I hope you guys are using them. Is there a problem, please? The HP prime which I have is different, so I do that differently. Let me see if the one given by the school this year can be used by one. See? That's not so difficult.
Oh. I was really scared you were gonna come back with a scientific calculator.
I mean, technically.
I know.
I was thinking like,
I don't know
oh
why
my
there's
God.
an F word.
Hmm? Wait, Verna, do you need help?
Verna, you can just type it straight.
谁用复习学习？上学几？
可是为啥我去不到？
有病啊你！
You don't need F1. No, it's like where's the F1? It's that's because it's a different model.
Are we there yet?
然后放
Talk to me, please.
I got it.
Okay, there we go. Got it.
找找到了。有呢個 function。
No, because so you have to change this to X.
嗰個 expert plus。
X.
呢個喂 drop。轉數。
Zoom. Right.
跟住你再撳得嗰個路監係1啊嘛，係咪1？呢個 execute。
Draw it. Then you get these. And then these all.
Yeah.
撳呢個
There's just one.
Six,
Because one's your lower bound, right?
Your
And
lower
then
bound.
my lower and then my upper bound is 2, right? And what do you
即係
execute?
我 enter 跟住再撳2 enter。
搞
哦，
掂。
跟住我就 OK。
我咁得意㗎，That's one looks so weird.
你係咪冇？你係咪
No, my one's not stretched out.
我哋 zoom in 就
好多暑假还是
No, like the
zoom in 咧，翻返去 zoom in 咧，跟住
Doesn't want one.
oh my god, how zoomed in are you guys?
Shall we?
You can actually sense it.
你而家咪要再撳多次
I got it.
點解啊？
Oh. Yeah, because that's you can just input it. So there's
好有可惜。
also so you can actually
Are we there yet?
Yes.
yeah, I got
All right.
Just hit the numbers.
So the reason I want you to do that is once we are doing some calculations, you can always use that function to check, okay? To be sure that you have not written minus where you're supposed to have plus, something like that. Now, please note that this calculator function is just showing you how to find definite integral. The calculator will not be responsible for this kind of case, especially between B and C. Am I making sense? So in that case, you're going to have a negative. And if you just do a direct integration from A to C, you might not be getting the correct answer. You get my point?
Yes.
So you have to put the right function in your calculator. So once you press that, you put 1 to 2, you know that that is just one part of it. You check the other part, or you could put with the absolute value directly, then you get the correct answer when checking. I hope everybody understands that.
Yes.
All right. So having said this, I'll keep this here in the PDF. Let's go back to... So let's see interesting question from here. Okay, I want you to try question 4. Question 4, B and C. No, let's start with, B, C, D. Okay, B, C, D. There's no need for A. So try question 4, B, C, D. Any luck? What is the first thing you should advise yourself to do before you just put directly in the integral sign? There was something you have to, I think I have to do this first. You should advise yourself on something. What is that?
Find the other,
Find the what?
find the other bound.
I can't hear what you mean.
Find the other bound.
What do you mean the other bound?
X.
You have a question, y equals x cubed, between the x-axis, x is equal to 1 and x is equal to 4. What other bound are you talking about?
Oh, P, sorry.
Yes? What is the first thing that is advisable for you to do when solving a problem like this? Say that again?
Sketch the graph.
Sketch the graph. Because if you do not sketch the graph, how do you know which of the categories it is? 1, 2, or 3? That is why you need to also get familiar with your calculator so you know how to sketch. So you are sure that between 1 and 4, none of the region is changing. Okay, there is no turning point in between. Because if this cubic function turns between 1 and 4, it's likely that some part of the region are above, some part are below. Okay? Or you can just in your mind find out the turning point. If you differentiate x cubed, you get 3x squared, right? So the turning point is somewhere at 0, right? And 0 is outside this range, so definitely there's no turning point. Am I making sense now? So the best thing is have a sketch of the graph. You have your calculator. I put a sketch on decimals that we can see. So this is x cubed. If I restrict the domain to 1 to 4, right?
Yeah.
1 to 4. 1 less than or equal to x, less than or equal to 4. So clearly, the region we are dealing with is on the same positive x-axis. This is what the entire curve will look like without restriction. Okay? So you are looking for this, the region between this and x is equal to 1 and x is equal to 4. So you are looking for this region bounded by the blue line, the curve, and the green line.